Alright, imagine that I have a square and I cut that square into 1/2, but I only shade 2/3 of this half. So, like this. Then I ask myself, how much of this whole square is shaded? That would be 1/3 of the whole square that is shaded. So that is what multiplying fractions look like. So in this, we did 2/3, which this colored part represents our 2/3. And then this whole part represents our 1/2. So it's 2/3 times 1/2. And eventually we get 1/3. I'm going to show how we multiply fractions after this. So don't worry quite yet. Alright, so to multiply fractions, we have this rule that emerges naturally, and it is A over B times C over D equals A times C over B times D. And A, B, C, and D are any numbers that you can cook up, or integers, I should say. Although sometimes we can't even have fractions in there. So, yeah. Okay. So if we have, let's take 1/4 times 2/6. This right here is my A, this is my B, C, and D. So then we have 1 times 2/4 times 6, which gives me 2/24. And then if you remember in our previous video when we were simplifying, this can be divided by 2 and this can be divided by 2, so we get 1/12 as our final answer. Now what if we had -2/3 times, let's do 1/5. It's going to be -2 times 1/3 times 5, which is -2/15. We can pull that negative out in the front, and voila, that is our final answer. So multiplying is different from adding and subtracting fractions. In fact, they are very different, so just keep that in mind. There's another thing. Let's say you have some crazy number like 25/100 times, let's do 7/5, right? I might not want to multiply 25 times 7. I certainly can. There's nothing stopping me. However, I can make this problem easier by doing cancellation. So what does that look like? Well, this is divisible by 5, and this is divisible by 5. And I can only do this diagonally. I can do the same thing diagonally this way, but not in this problem, because this problem 100 and 7 share nothing in common, but 25 and 5 do. So then it becomes 5/100 times 7/1. And then I can multiply across, and I get 35/100 as my final answer. let's do it this way. 25 times 7 over 100 times 5. We get, let's see, 25 times 4 is 100. So we get 175 on the top and 500 on the bottom. And if we divide both of them by 5 to make it a simplified fraction, we get 135. All right. Now, how do we divide fractions? So I like to think of keep, change, and flip. And the way I remember this is I literally just think of Kentucky Fried Chicken. Even though it's KCF, I think division in fractions gives me Kentucky Fried Chicken, and then I'm like, but wait, it's actually KCF. I don't know. You can find little quirks and little things to help you remember things in math, and yeah, this is just mine. I don't know if you would want to keep that or not, but yeah. Okay, so we have this rule, keep, change, flip, where let's say I have 1 over 2 divided by 2 over 3. This is also the same thing as 1 over 2 over 2 over 3. So it's like a fraction over a fraction. So what happens is I'm going to keep this left side. I'm going to change this to multiplication, and then that is going to flip. So we're going to keep this. We're going to change it to multiplication, and then the 2 and the 3 are going to switch spots. They're going to flip. And so now I have a multiplication problem, and what can we do? We can multiply across. So 1 times 3 over 2 times 2, which gives me 3 over 4. But what if I have something like 2 over 3 over 5? And 5 is just a whole number, a regular number, if you must. Well, if you can recall, if we have any number over 1, it's going to be that numerator, right? So then what happens is we can throw this 5 over a 1, and if we apply our Kentucky Fried Chicken rule, well, then we have 2 over 3 times 1 over 5. I mean, technically you can do Kentucky Fried Chicken, right? Because we're keeping this, we're flipping this, if you think of flipping as division to multiplication, and then we're changing that. They're kind of the same thing, right? But yeah. Anyway, so then our problem becomes a multiplication problem, and we can just multiply across, and we get 2 over 15 as our final answer. And we can apply this same logic to a situation where we have, let's do 5 over 2 over 3. Let's throw that 5 over a 1 over 2 over 3. And then it becomes 5 over 1 times 3 over 2. And we get 15 over 2 as our final answer. Alright, so here are some practice problems for you guys. I will say that these are a little bit harder, but just try to remember something that we did up here. It will help you. And as always, I'll give the answers at the end of the video.